Okay, so today's topic is exponents, and truthfully, we've already done some work with exponents before. There was a question on, well actually no, we've actually been doing this with our square and cube roots. For example, I'm going to start here. When we talk about square roots, you guys all know the square root of 9 is 3. But I want to make sure I'm really clear as to why the cube root of 9 is 3. Here's the rationale. 9 is really 3 and 3, right? Another way of writing 3 and 3 is to call it 3 squared. This symbol right here, the exponent of 2, it is the opposite of the square root sign. You know how adding and subtracting are opposites of each other? Multiplying and dividing are opposites of each other? Well, squaring something and square rooting it, they're opposites of each other. So essentially what happens is, that cancels out. But you guys have just been taught to memorize things, right? So the square root of square root of 4 is 2, 9 is 3, 25 is 5. That makes sense? So I know you guys have some experience with exponents before. Essentially when you have the exponent, it just means you repeat it that many times. The first thing I should point out, yeah, go for it. It's always multiply. So whenever you're multiplying these things together with this power of 3, don't add. A common mistake is that kids will add them. If I were to give you this this setup right here, just want to write this out. What does x to the 3 really mean? Well, it means x times x times x. That's what x to the power of 3 means. You have 3 x's that are multiplied by each other. Let's say you made that mistake though, and you thought that it was x plus x plus x. What's that actually? Anybody know? Let's say you screwed up the times and the multiply, or the times and the add. We want to take a guess as what x plus x plus x is. 3x. Good job, whoever said that loud enough. There's a very big difference between these two things here. 3x means x plus x plus x. Essentially, you're adding like terms. You know how if you have 2x plus 3x is equal to 5x? We can put those things together and combine them in a plus form, an addition form. But when we talk about exponents, the first thing I need you guys to know is that it's always multiply. So if we ever have x times x times x, please do not write this as that you have 3 x's. Okay, in a way, yes, you do have 3 x's, but when they're multiplied by each other, we write it in this notation here. We write that it's equal to x to the power of 3. Does that make sense? So that's what my first slide talks about here. Make sure that you know that this base right here and this exponent tells you how many times that we are multiplying, not adding. So this next slide talks a little about some of the terminology we've been using. The one I've got here is like terms. See how this 2x right here and this 3x right here, they can get combined and turned into 5x? Here's the reason why. This 2x, what does it mean? Well, it means that you have x plus x. You have 2 x's added to each other. What does this 3x right here mean? Well, it means you have x plus x plus x. You have 3 x's. Again, though, added to each other. Not multiplied, but added. So 2 and 3 is 5, right? Because you have 1, 2, 3, 4, 5 x's all being added to each other. But for this to work, they have to be considered like terms. Can I put this 4 with the 2x? It doesn't really work in the same way, does it, right? Because really what the 4 is it's 1 plus 1 plus 1 plus 1. That's what 4 is. Can you put a 1 and an x together? No, they're not like terms. We've even done this before with our square root, our radicals. Here you have 3 root 5s. We have 4 more root 5s. In a way, here's what this means. You have a root 5 plus another root 5 plus another root 5. That's what 3 root 5s means. We're adding them all together. This 4 root 5s means you have 4 of them all being added together. So, I mean, you guys know your basic math skills, right? If you have 3 of them added together and 4 of them added together, you have 7 of them added together. but it has to be the same thing on the square root side. If it's not, it doesn't work. Today then, we're going to work on how to deal with this if we've got exponents. And very, very similar rules apply in that you have to have something called like bases. If the base of the exponent is the same, there's a whole bunch of rules that we can use for simplifying. Again, remember what our unit is. Our unit is all about operations and numbers. So we're going to talk about how to add, subtract, multiply, and divide. Pretty much any number you can think of. Whole numbers, integers, decimals, square root numbers. Well, today we're just going to add on anything that has an exponent. So maybe you've seen this before. X to the 4 times x to the 5. The rule is you actually add the exponents and make it x to the 9. Has anyone ever seen that rule before where you've been shown that? Here's the bigger question. Do you understand the why that works, or did you just memorize a rule? Memorize it? Well, let's show you why this works. What does x to the 4 actually mean? It means you have 4 x's, but not added to each other, multiplied by each other. So I'm going to write this out. This means that you have 1, 2, 3, 4 x's multiplied by each other. This x to the 5, I'll write it on top, means that you have 5 x's multiplied by each other. And you see how in between there was a multiply sign? Because of that, really, it's almost like a big list continues. I'll see if I can even pick this up and show you this. It's almost like these 5 x's go directly next to the other 4 with a time sign in between. Well, now count them up. How many x's do we have? We have 9 x's, all being multiplied by each other. So you might have been taught this rule before, but essentially the rule is if you have 2 same bases, similar like bases, and you multiply actually means add. Divide then means subtract. Let's show you why. What does x to the 8 mean? It means you have 8 x's multiplied by each other. So I'll even write them all out. 1, 2, 3, 4, 5, 6, 7, 8 x's. And the bottom of the fraction x to the 5. It means you have 5 x's in the bottom of the fraction. You guys know what happens when you have something on the top and bottom of a fraction that's the same, right? It cancels. You heard that phrase before? So watch this. This x can cancel with that one. This one can cancel this one. This one can cancel that one. This one, this one, this one, that one. Okay, I ran out of x's to cancel. How many are left? So the answer is 3x. No. X plus x plus x is 3x. These guys, I didn't write the little symbol there, but they're multiplied by each other. So it's x to the power of 3. So you may have seen this rule before. If you multiply, actually you add. And if you divide, you subtract. Some of you have seen this before? So we're going to focus on those today. Here are a whole bunch of rules that apparently you learned at some point. Kind of like with the long division though, I'll understand if you forgot. But this is actually stuff that I believe is great, what I've been told. So I'm going to do some review on some of these exponent rules today, and then we're going to try applying them to our operations of adding, subtracting, multiplying, and dividing. So let's walk through some of these. Here's a rule. If you have x to a power and x to another power, we add them together. That's what I just showed you. If you have 3x to the 3, that means 3 x's. If you have x to the 4, you have 4 of them. Really, what you have is a big list of a whole bunch of x's just being times by each other. So you can add them. When you divide, though, they cancel. So these are the first 2 rules that were just on the last slide. Let's talk about this one here. I'm going to make up some values to go with. Let's say we have x to the 2 to the power of 3. Let's say that was the example. The rule here is that whatever these 2 numbers are, you multiply them. The answer is going to be x to the 6. Well, let's talk about why, though. This power of 3 right here means you have 3 of them, right? So what you have is x squared times another x squared times another x squared. Well, what do each of the x squareds mean? Well, they all mean you have two of them. Again, times by each other. Two more times by each other. Two more times by each other. So I mean, add them up. How many do you have? You have 6 of them times by each other. So often what we'll do is we'll show you a rule that says if you have like a bracket around these guys to another power, you actually times those numbers together. That's something familiar you guys have learned before? If not, we'll work on it. Here's another rule. Let's say that you have 2 variables. We're actually going to start moving into this very soon here, where we don't just have x's, but we have x's and y's. What ends up happening is this number right here, let's just do an example here. Let's say we have x, y to the power of 2. What does x, y to the power of 2 mean? Well, it means you have x, y, and then you have another x, y of 2. How many x's are there? There's 2 of them, right? I mean, one's right here, and one's right here, but there are 2 of them, right? But I don't write it as 2x, though. Why not 2x? What does 2x mean? But these are clearly being multiplied, right? So don't do 2x. But you'd agree we have 2 of them, which means we write it as x squared. And then we also have 2 y's, right? So we call it y squared. Essentially what happens is this exponent right here, it applies to both of the terms inside. So you have to make sure that you actually square or cube both of those individually. Okay, there's a similar rule for dividing. I'm not going to take the time to go through that because I do have more examples on this. This one right here may be new. I'm not sure that you've seen this before. Are you doing the grade 9 now? I don't know whether you do that grade 9.
Not really.
Okay. And this one right here may also be new. So I'm going to leave these ones until I have actual slides on them. So why don't we hop into a bunch of examples? Because sometimes that's the best way to learn, is to do a whole bunch of examples, see whether you guys retain this up. So let's try combining these as exponents. 5 squared and 5 to the 6. If you'd like to, you could just go right to the answer. It's 5 to the 8. Okay, let's talk about y. 5 squared means you have 2 5s times by each other, right? 5 to the 6th means you have 6 5s times by each other. But I mean, in between, they're also being times, right? So it's the big consecutive string of timesing numbers together. How many 5s do we have? We have 8 of them, right? 1, 2, 3, 4, 5. You can count, right? So it's 5 to the 8. Don't do this, though. This is a really, really bad mistake. Don't say that you have 8 5s. Because 8 times 5 means that you have 5 plus 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 5. It means you have 8 groups of 5. We don't have 8 groups of 5. That's not correct. You have to go to power. Once you get the hang of it, you just look at the 2 exponents and you add them. Or in this example here, subtract them. That's all right. So 9 and 7, 2. Yeah, 3 to the power 2. So far, so good? What about this one here? Well, let's talk about what this means. This means that you have 3 written out 9 times. So bear with me while I write out all 9 of them. Probably should have chosen a smarter example. Then this means you have 5 written out 7 times. 1, 2, 3, 4, 5, 6, 7. Does anything cancel? You have a whole schwackload of 3s on top. You have a few less of the 5s on the bottom. But does anything actually have the ability to straight up cancel? No. How do I undo this? Let's say that it had not been to the 9, or that this wasn't a 3. Let's say this one was a 3 like the one there. Well, if all of these were 3s, then can I start canceling? Yeah, totally. So one of the things that I need you guys to start getting as we go through this unit on numbers is that we're going to work on practicing how to add, subtract, multiply, divide all sorts of numbers. Sometimes they actually can't go together. If I were to ask you to try to combine root 2 and root 3, they can't be added together. Like, sometimes the answer is this is where we're stuck at. This would be another good example of that. Sometimes you can't. If I asked you root 2 3 times root 2 times root 3, sure, that might be possible. Let's have some more examples. 2 to the 3 to the power of 2. So it helps if you have your rules memorized. But let's say that just for some reason you forgot all your rules. What does the power of 2 right here mean? Well, it means that you have it twice. What do you have twice? You have that thing twice. 2 to the 3, we need it twice. We have 2 of them times by each other. Well, this power of 3 means you have 3 2's, and this one here means you have 3 2's, and hopefully by now I'm really boring you. Because really, what do you do with these guys right here? Times them together. If these guys are like a bracket on each side of each other, like this, they actually multiply. If you have 2 of them independently, we add. But if you just have one of them with an extra bracket around it, actually multiply those numbers. Let's try this one here. What does 4x squared mean? Well, it means 4x times by another 4x. How many 4's do we have? So 4 plus 4 is 8, right? Because we're multiplying, right? So in a way, we have numbers that can go together. The 4 and the 4, they can times by each other. That'll give us 16. Then we have an x and an x. 2x or x squared? X squared, right? Because they're being multiplied. So the answer for this one is 16x squared. Here's a faster way of doing that, though. Maybe I'm taking way too long and you're getting bored here. Really what you need to do is you need to square the x, and you need to square the 4. So 4 squared is 16, and 4x is x squared. Once you get the hang of these rules that I have back here, and hopefully you guys have a little bit of experience with these? I'm trying to gauge your reaction by like how much this is familiar. You did it before? Okay. I mean, this is something that we have worked on in the past. Here's my advice then. If you're looking at me like, I don't remember doing this, Chris. I got to do a tank full of questions for you, okay? Well, let's do some practice. How about this one here? What's the rule for divide? If they have similar bases. Do they have similar bases? Okay. What is 3 minus 5 though? Yeah, it'll be 3 to the power of negative 2. I'm going to pause here for a second, because that is the answer. But what does 3 to the negative 2 mean? Like, I can look up what 2 to the 6 is in my calculator. It's probably like 32 or 64 or something like that. But can we have negative exponents? Is that allowed? And actually, it is. It's actually a big focus of where we're going to go now in grade 10. Negative numbers are integers. We're going to focus on how to deal with negatives. So that's where my next slides go, is talk about what happens if you have something and you have a negative as the exponent. And there's actually a really a rule behind how this works. If you ever have a negative exponent, it actually turns it into a fraction. I want to do some examples. You guys have a calculator nearby? If you have a calculator, do this with me. If not, just watch. I have a calculator you can see just right on my smartboard, actually. It's kind of cool. I'm just going to try practicing some exponents. Do you guys know where the exponent button is on most calculators? If you have one of these ones, it's this little arrow right here. That's the exponent button right here. This little like kind of up pointing triangle. If you're using a calculator like this, sometimes the button is like X, Y, something along those lines. In calculators, it's an exponent button. Let's do some examples. What is 2 to the power of 2? I'm not even going to press enter yet. 2 times 2 is 4. What is 3 to the power of 2? 3 squared is 9. I want to try something different here. What if I go 2 to the power of negative 2? Do you think I can throw in a negative number? What happened there? It didn't get bigger. It got smaller. But hang on. Isn't that kind of how positives and negatives work with each other, right? I mean, positive direction might make things larger. If I had a negative exponent, look how it made this thing a decimal number. Let's do some more examples. What if I go 3 to the power of negative 2? It's a decimal number. It's got smaller. Let's just pick random numbers. 500 to the power of negative 17. Actually, that's a poor example. Have you guys ever seen what this little E notation means? Might have gotten too far here. We picked something not so drastic. Let's go 500 to the power of negative 3. Still isn't going to work. Has anybody seen this little notation before? Okay, I will get to that. Sorry, I showed you something maybe out of sequence here. 12 to the power of negative 2. There we go. Do you guys see how the negative exponent, though, makes it a really small decimal number? The long and short of what I want to show you here is that we can actually deal with negative exponents. It's just it's the opposite. Normally when you square a number, you're making it larger. 2 times 2 is 4. Makes it bigger. 3 squared. 3 times 3 is 9. Makes it bigger. But if you go 3 to the power of a negative number, it actually makes it a smaller value. So here's the rule behind it then. If you ever have a negative exponent, it actually becomes a fraction. It becomes 1 over top of whatever the same thing would have been, except get rid of the negative sign. So here's an example. 2 to the negative 2. 2 to the 2 is normally 4, right? But that makes it bigger. We actually need to make these numbers smaller. So we're going to make it 2 to the 2, but we're going to make it 1 over 2 to the 2. This answer is actually 1 over 4. Let's try this again. If I go 2 to the power of negative 2, the calculator spits out 0.25. That is 1 over 4. This is the big part of my lesson today, because I'm fairly confident that at some point you guys have learned some of your other exponent rules. This is the new one. How can we deal with integers? How do we deal with negative numbers? Oh, just save this thing. It's okay. So let's try an example here. Can we write this as an exponent? 1 over 3 as an exponent? No, what would it be? That's what it would be, yeah. This is going to be 3 to negative 1. Let's explain why. Is there an exponent on the bottom of this fraction? Well, not really. But in a way, I could just kind of say there's 1, 3 on the bottom, right? If there's 1, 3 on the bottom, the way that negative exponents work is that whatever's on the bottom, that's the negative exponent. Let's try it out here. 1 divided by 3. 0.3 repeated. Well, if I try going 3 to the power of a negative number should, rather than make it be larger groups, it actually makes it smaller groups. It ends up being the same thing. So we could try that same logic for the next one. There's a 4 on the bottom, right? So I could write that as 4 to the 1. So one way I could write this then is it's 4 to the negative 1. What ends up happening is this negative exponent really indicates that the number was on the bottom of a fraction. Let's try it. 1 over 4. 0.25. 4 to the power of a negative number will actually turn it into a fraction. Here's the weird thing about this one, though. That's not the only way we could write it. Rather than writing it as 1 over 4, isn't 4 really equal to 2 by 2? 2 by 2 is 2 squared. See how I have a number on the bottom of a fraction? That means that I need to have a negative exponent. Well, the exponent could be 2 if I let the base be 2. This would also do. Rather than having 4 to the negative 1, I can actually go 2 to the negative 2. That would actually work just as well. Because isn't 4 really just 2 2s? Since it's on the bottom of a fraction, the rule is we actually make it a negative exponent. Has anybody seen this before? Or is this the new thing today? I was pretty sure this was going to be the new part. Okay, so let's do some work on this one. One more rule I want to talk about, though, is the 0 rule. What does 2 to the 7 mean? Well, in a way, 2 to the 7 means you have 1, 2, 3, 4, 5, 6, 7 2's. But you could always times by 1, because doesn't timesing by 1 really do nothing, in a way? Right? So if I didn't want to include the times by 1, I don't have to, but I could times by 1. What does 2 to the 3 mean? Well, it means you have 1, 2, 3 2's. But could I times by 1 if I wanted to? Doesn't change the number, right? What if I give you 2 to the 0? 2 to the 0 means you have no 2's. But I could still have no 2's and still times by 1. Wouldn't that logic still kind of make sense? So this is the last rule I need to show you. If you ever have an exponent to the power of 0, I don't care what it is, but we always define it as the number 1. 17, oh, I can't remember it. 17x to the power of 0 is always 1. Because what it means is that you have 17x written no times, and then you could always times by 1 if you want. So something written no times doesn't mean the answer itself is 0. Sometimes people want to say that this answer itself is 0, but it's not. Let me show you an example. 2 to the power of 0 is 1. 9 to the power of 0 is 1. 789, and I'm just going to type in as many random digits as I can, to the power of 0 is 1. The logic being, you're not writing the number at all, but the number that you're not writing at all could always be times by. Okay, so those are rules. Let's try some more examples. Oh, I almost forgot. I need to do one more thing. You know how the exponents, I just talked about how to deal with negative exponents? What if the exponents are fractions? People usually really struggle with fractions. So what I want to do is I want to talk about a quick review on how to add fractions, because we may need to do that. If I ask you to add 2 over 5 and 1 over 5, it's actually very similar to like terms. What I'm asking you to do is add 2 fifths plus 1 fifth. Isn't this kind of like adding 2x plus 1x? Isn't the thing that we're adding? It's the same on both of them, right? So the rule for adding or subtracting things that are fractions is you better have the same fraction on the bottom as a common denominator. So I want to do a quick tutorial on how to redo fractions before we get to the next questions. So here's a slide I found on the internet that just shows you how to deal with this. Let's say you have 4 over 3 minus 2 over 7. Are you adding and subtracting the same sort of like terms? I'd say no, you're not. Here you're adding 4 thirds. Here you're subtracting 2 sevenths. This would be like 4x minus 2w. You can't put them together. Well, not yet at least. So the trick here, we make sure they get a common denominator by multiplying so that they're the same. What's the lowest common multiple between 3 and 7? 21. Because like 3 goes 3, 6, 9, 12, 15, 18, 21. 7 goes 7, 14, 21. So since 21 is the lowest common multiple, we're going to use that as the bottom of a fraction. We just need to get there. So the way we do this is we times both the top and the bottom of a fraction by whatever number it takes to turn our value into that multiple of 21. How do you turn a 3 into a 21? Times by 7. Here's the rule though. Can I just randomly times the bottom of a fraction by 7? Unfortunately, that's not valid mathematically. If I times the top of the fraction by 7, it's almost like I times by 7 over 7. What is 7 over 7 though? Can I times by 1? Always. That doesn't change the thing. You guys have learned how to multiply fractions and add fractions, I'm sure, at some point. But I bet you it's been a while. So this may be another skill. Remember that Jenga pyramid I talked about here? You may have a fairly weak base of fractions. So it may be something we want to work on. That's not the whole point of my lesson today. The point of the lesson today is how to work with exponents. So if the fraction thing catches you, can we have a conversation at some point? And I will redo some work with fractions with you guys. Okay, let's do some examples. Can I put these things together? Do they have like bases? Yeah, they're both 5s. But how do I deal with it if it's a fraction? Well, the same rules still apply. What do you do when you multiply if they have a like basis? What do you do with the 2 exponents? You add them. So we need to then have some pretty good adding skills. So I'm going to do a brief aside here. What is 1 over 3 plus 5 over 3? Do they have the same denominator? Are we talking about the same thing? Yeah. What is 1 third plus 5 thirds? 6 thirds. because 1 plus 5 equals 6. If I lose you on this step here, we'll do a tutorial on fractions later, okay? Because again, fractions are something we have covered in the past, and I want to focus more on the exponents, but if this makes me lose you, we'll chat later, okay? 6 over 3, can't we reduce that? What's 6 over 3? 1. So what I've done here is I've taken my two fractions and I've added them together. 1/3 and 5/3 is 6/3. 6/3 is 2. So my final answer is 5. That base is still there, right? 10 to the power of 2. What's the rule when we divide? Dividing exponent things means to subtract. So I'm going to take these two fraction numbers and I'm going to subtract them. So I'm just going to do a brief aside. What is 1/2 minus 3/2? Can we put them together just as they are right now? Do they have the right denominators? Yeah, they're both 2's, right? So what is 1/2 minus 3/2? 1 minus 3. So we have -2/2. Okay. This is kind of like 1x minus 3x equals -2x. Except all of the x's we're talking about are the bottoms of fractions. What's 2 divided by 2? 1, right? So really this is just -1. Okay, so here we had to add them. We keep the base though, but it still stays a 5. It's 5 to the power of what we get. So what do we get on this decimal table? We still have our base of 4. This base was 4, this base was 4. My answer's base is going to be 4. When I subtracted my fractions, I got -1. We're not done though. What did that negative exponent mean? What do negative exponents do to numbers? They turn them into fractions. So this ends up being 1/. That's what the negative does. This negative makes it 1 / top of. It makes it a decimal number. It makes it 1 / top of 4 to the 1. So the best answer for this is to call it 1 / 4. That's what this would be equivalent to. 1 / 4. So we're going to start putting a lot of skills together really fast here. In order to solve a question like this, you need to have a pretty firm grip on first how the exponent rules work, which was that you need to subtract numbers. Second, you need to have a really good grip on how to deal with fractions, which is not most people's favorite thing to deal with. So if we need practice on fractions, I got a whole bunch of questions in there. We can work together. And then lastly, I had to remember another rule, which is that when you have a negative exponent, it actually puts something on the bottom of a fraction. Let's try this one. Is this physically possible to put these two numbers together? Do they have the same base? They do have the same base. Hypothetically, let's say it was this. Let's say it was 2 to the 2 times 2 to the 3. Could we put those together? What would it be? It would be 2 to the 5. Because you would add those together. Well, the rationale for this is you have 2 2's here, you have, you have 3 2's here. Look, I have 5 2's. It's not as easy to see those fractions. The same thing applies though, we just need to add those numbers there. So as a little bit of an aside here, we need to be able to add 1/2 and 1/3. So I need to go back to like grade 6 fractions? Maybe like fractions? Can these be added together as they are? Do they have the same denominator? They don't, right? One's a 2 and one's a 3. If they're not the same, we have to make them the same. So as an aside here, if this is the step that loses you right here, let's work on fractions in a little while, okay? What's the lowest common multiple between 2 and 3? 6, yeah, let's just do a list here. 2 would give you 4, would give you 6, 3 would give you 6, so it looks like 6 is the lowest multiple between them. So how do I turn this 2 right here into a 6? Times it by 3. But you gotta times both the top and the bottom by 3. How do you turn this 3 into a 6? Yeah, times by 2. You said 2. Okay. So now what we're going to have is these are now both going to be fractions that are over top of 6, which is good because we need to have sixths that we're adding. You can't add seconds and thirds, but if they're the same, you can. 3 times 1 is 3, and 1 times 2 is 2. So now what I need you to do is take 3 sixths, add 2 sixths. In a way, this is like 3 sixths plus 2 sixths, or 3x plus 2x. Can they go together now? Yeah, 3 and 2 is 5. 5 what's? 5 sixths. Okay, all of that work was just to figure out what the exponent's going to be. So for the last little bit here, you know how this 2 and this 3 added to get 5? This 1/2 and this 1/3 added to get us 5 sixths. So our final answer is, the base is still 2. That's the power of 5 sixths. We can still deal with this. It's just rather than having nice whole numbers, I need you guys to get more familiar now with your integers. Integers include negative numbers, and things like fractions. That's where the big twist in grade 10 now comes in. It's not just whole numbers the whole time. The pace sure moves fast, eh? Like, this is a big jump where all of a sudden I have to take a bunch of little skills and put them together. And that's why I really like my Jenga pyramid analogy. Because if you're missing even one of those little skills, if adding fractions all of a sudden went over your head, if the exponent rules from grade 9 went over your head, right? Even if you're struggling with basic things like, well, what's 3 plus 2? If you're missing any of those pieces on the Jenga tower, you can see why this all of a sudden topples over real soon, right? And that's the big difference, I think, between grade 9 and grade 10. Is that the pace at which we go is a lot faster. We really need to have that firm foundation. Let's try some more examples. What if I don't give you a number? What if I give you x? Does that change anything? Or can we still deal with it? What's the rule for exponents when they're around brackets like that? You just multiply them, right? So 6 times 2, 12. That's not so bad, right? But you do have to have a firm grasp on your rules, right? You have to know what this means. This means 6 x's. And you're doing it twice. I'm not going to write them all up, but you can kind of envision, right? There's going to be 12 of them there when you're done. Well, what happens now? What happens if I can do 6 times 2 for 12, right? Doesn't the same logic apply here? Won't these numbers here have to multiply by each other? Well, we need to re-go over how to multiply fractions. What is 6 times 2 over 3? Do you guys remember how to multiply a fraction? Or has it been a while? What was that? Okay, so the rule for multiplying fractions is you take the tops of fractions, you multiply them by each other. You take the bottoms of fractions, you multiply them by each other. Is this 6 right here a fraction? No, it is if you're really clever. It's 6 over 1. Because doesn't dividing by 1 not really change anything? So then 6 times 2 is 12. 1 times 3 is 3. It's actually 12 over 3. Okay, again, as a brief aside here, if I lose you on this step here, the reason why I'm moving on is because that's not actually the new curriculum. That's something that you would have learned in the past. If you know that there is a big hole in your Jenga tower right there, we need to chat. Okay? And I'll help you fix it. But if I just lost you right there on how to multiply that, the reason why I'm not taking a lot of time on that is that's not really the new skill. 12 over 3 is 4, right? So our final answer is, our base is x to the power 4. Again, what is our unit? Our unit is numbers, right? I need you guys to be able to add, subtract, multiply, and divide pretty much any number we can think of. A fraction number, an integer number, exponent numbers, square root numbers. I'm really going to stress your skills on this. let's get to our last one too. So this is kind of where the extension finally takes us to. What do I do here then? Can I put this x and the y, can I put those ones together? No. But can I put those ones together? Yeah. How many x's will I have? Well, 3 here and 2 there means I'll have 5 x's. What about with the y's? If I have 2 y's here and minus 4 y's there, I'm still multiplying though, aren't I? Doesn't the implied symbol between these mean multiply? So multiply still means to add, so what's 2 plus minus 4? Minus 2, can we have minus 2's? Yeah, we've been working on it today, right? But what does a minus 2 mean though? A negative exponent puts it on the bottom of a fraction. So the x to the 5 will actually stay where it is, but the y squared is going to go on the bottom of a fraction. This is how we answer that. That negative 2 basically means take this whole thing and put it underneath. Because what we're actually doing is we're going to make the number smaller. What about this one here? Are we multiplying or dividing? This symbol right here means we're dividing, right? Okay. So let's start with the numbers first then. Can you divide 10 by 2? Hopefully you know it right away, right? That's 5. Okay, well the rule for dividing is you subtract, right? So a to the 5, subtract a to the 2. 5 subtract 2 means you should have 3 of them left. And can I deal with this negative? Well, sure. That's the whole point of this new lesson here. You have to do 3, subtract negative 2. What if you do a 3 subtract negative 2? Actually makes it, yeah, makes it positive. So we actually have b to the 5. Do I need to have the bottom of a fraction anymore? No. If one of these guys was negative, sure, I'd pop it on the bottom of a fraction just like I did right here. I don't need to in this case. Okay, well, let's keep building. What do I do here? Let's start on the inside of the fraction here, or the inside of the brackets, right here. See how these guys are directly next to each other? They're multiplied, but what does multiply mean for our exponents? Add them. Okay, so just for this little bit right here, we need to add the exponents. So how do we add 3 and 3 over 2? So you need to have some pretty good fraction skills again, right? So again, if you're stuck on how to do this, I might suggest it's like 3 over 1. Okay, I'll times this by 2, I'll times this by 2. I'll get 6 over 2 plus 3 over 2. 6 halves plus 3 halves means I have 9 halves. So in order to add these exponents right here, that's apparently what it adds to. That's 9 halves. But look, then there's this extra 1 half up here. How do I do with these ones going together? Multiply them this time. See how these guys both have their own individual basis? For that rule, you add them. But if you go to the power of another one, you actually have to multiply. So now I need you to practice your multiplying of fractions. What's 9 over 2 times by 1 over 2? This one's actually way easy. You just times across. 9 times 1 is 9. And 2 times 2 is 4. Okay. So our final answer is our base is still x. And the final thing is the power of this. Hopefully you guys can kind of see how this kind of has been building to this point. If you struggle with adding decimal numbers, if you struggle with multiplying fractions, if you struggle with any of the previous skills, that's why I've got that Jenga analogy there, because it really builds fast. And so I very sincerely, when I mean this, I will help you guys with any previous skill you're lacking, but I need you guys to be able to help self-assess and figure out if you are missing something, if you know that you struggle with something that you learned in a previous grade, there's no way that you'll be successful moving forward if there's still a hole in that tower there, even if it's just a little one. So if you guys want a tutorial on fractions, tomorrow during focus time, for any of you who want a tutorial on fractions, I can do a whole bunch of work on that with you on the middle table if you want. If you don't, that's fine. But I need you guys to self-assess, figure out where your struggles are. I am running out of time. How many examples do I have left? Just 2. Okay, I think we should finish. Just perfect. How about this one here? I mean, it's starting to look intimidating, isn't it? Right? I mean, there is a negative exponent. That stinks. There is a fraction. That's not exactly easy to deal with either. And we got to divide these things. Where should we start? Let's start inside the brackets. What's the rule for dividing things? Subtract. Okay. So 3 minus 6. Okay. Why don't we first go with that? X to the minus 3. I'll deal with the minuses in a bit. Because I know minuses do mean bottoms of fractions. But we still have another operation here. See how these 2 things are here? What's the rule if there's just a single base and then it's to a power? Multiply. Multiply. So minus 3 needs to multiply by minus 2 over 3. So again, this is the step I'm going to gloss over a little bit here. If you're not great with fractions, we better work on this. I would do this. I'd make it negative 3 over 1 and then just times across. 3 times 2 on the top is 6. 1 times 3 on the bottom is 3. What happens when you times 2 negative numbers by each other? Positive, right? So I guess we can just make that plus. 6 over 3, 6 divided by 3 is 2. So I guess our final answer is we have x to the power of 2. Who would have thought that that simplifies to that? One last example. Just perfect timing here. Can these go together? Do they have the same base? They don't, do they? Right? Because all along I've been showing you that if it's 3x and 4y, if they don't have the same thing, well then you can't do anything. But sometimes you can play a really nifty trick here. Watch this. 36. Isn't 36 just 6 squared? Watch where this takes us then. I'm going to rewrite it. 6 to the minus 2. Rather than calling 36 36, let's call it 6 squared, because isn't it? Right? 6 times 6 is 36. We can actually still do this. We just have to get our order of operations right. The thing I should do first, I think, is this bit right down here. So what's the rule for this? If you have 6 to the 2, around the bracket of the negative 1/2, we multiply. Yeah. So we need to do 2 times negative 1/2. Two times minus 1 is minus 2. 1 times 2 is 2. Okay, I got minus 1 when I'm done. So really, this whole bottom of the fraction here, if I write it with a base of 6, rather than as 36, we're playing this little nifty trick here. The whole bottom of the fraction is actually 6 to the minus 1. This is cool. Now, do they have the same base? Absolutely, right? So the rule for dividing is subtract. Let's get this right then. Minus 2, subtract, minus 1. Man, you gotta get your integers down, right? What happens when you do a double subtract? Okay, so minus 2 add 1 is, actually it's minus 1, right? You're minus 2 in the whole, you go back up by 1, now you're only minus 1 in the whole. So we're almost there, we're not quite done though. We now have 6 to the minus 1. One last thing though. If we end up with a negative exponent, it's actually a fraction. A positive exponent, 3 times 3 is 9, a bigger number. 3 to the negative 3 actually makes it a fraction number. So the final thing we do is we would say this is 1 over 6. And we might write that little 1 right there. This 1 right here, we might write it there, but we probably wouldn't bother. We'd probably just leave it as 1 over 6. That's the answer here. We just picked up the pace, eh? Hopefully you probably noticed that all of a sudden it went from going about this speed to way, way, way faster. I I really think that's going to be one of the biggest differences you guys discover when you get your grades in here. So good news is though, tomorrow and Wednesday we have work days and there's focus time. Okay. If you struggle with fractions even a little bit, we should talk. Okay. So that was our bell, right? So that just go there, that little buzz. So we'll see you guys tomorrow. Okay. We'll start working on this.